Alright, this is the video for Algebra 2, Lesson 6. Alright, so we're going to be talking about equations with decimal numbers and consecutive integer word problems. The first thing we're going to do is equations with decimal numbers. So we're going to start off with their example 6.1, and that is 0.0, they got 0.003x plus 0.4 equals 2.05. Alright, so you could solve it just like that, but the easiest way to solve this is to get rid of all these decimal places. So if I multiply this whole thing times 100, so I can count and say, okay, I've got 1, 2, 3. Actually, I'm going to multiply it times 1,000. So I've got 3 places to my decimal. So you'll see what happens when we do that. So we're going to multiply this whole thing times 1,000, which means we have to move this one 3, and we get 3x. Now if we move this one 3, 1, 2, 3, we're going to get 400. If we move this one 3, we're going to get 2, 1, 2, 3. Alright, see how that's easier to deal with? 1, 2, 3, yes. It's easier to deal with than all those decimal places. Alright, now we're just going to say minus 400 on both sides. And that's going to be that 3x equals, and then we've got to divide by 3. So I got 1650 divided by 3 times 5 is 15. 550. So x equals 550. See how it was easier to deal with than if we'd left those decimals in there. So you just count the highest number of decimal places that you have and then multiply by that many zeros on the end. Alright. See if there's another one here. Okay, so it says the students found that 0.015 of the teachers were either brave or completely fearless. If 300 teachers fell into one of these categories, how many teachers were there in all? Okay, so we've got what number times of equals is. Remember, that's how we figure these out. And it says the students found that 0.015, that's going to be what our decimal. So you can say what decimal, okay? So we know the decimal is 0.015 of its times the teachers were either brave or completely fearless. If the 300 teachers fell into one of these categories, how many of the teachers were there in all? Teachers. Alright, so that's saying equals 300. Okay, so 300 of the teachers were this number. So we're trying to figure out how many teachers there were in all. So 0.015 of the teachers equals 300. Okay, that's not the total number. These are just the brave or fearless teachers. We're going to say brave teachers. And we're trying to find out the total number. So if we did it like we drew a diagram and we said this little bitty part right here, 0.015, and this would be all of it, so that'd be 1, right? This is 300. It's this little bitty piece. And we're trying to figure out what all of 1 is. Okay? Alright, so that means we're just going to divide by 0.015 and divide this side by 0.015. Now you notice something kind of cool when you divide by a decimal. We have 300. And we're dividing by 0.015. We move our decimal 1, 2, 3. 1, 2, 3. And we divide that out. 15 times 2 is 30, and then we're just going to bring all these zeros up, and the answer is 20,000. So the whole thing is 20,000. utterances showed that 0.932 were fatiginal, whatever that is. If she spoke 2,000 times during the period in question, how many utterances were not whatever? Okay, so if we draw a diagram of that, we would say 0.932 of all this, if the whole thing is 1, 0.932, that's almost all of it. Okay, and these were fatigial, whatever that word is, and these were not. Okay, so almost all of it, and that's 0.932. And she spoke 2,000 times. That means 1 equals 2,000. The whole thing, one whole of the amount of times that every single time that she spoke equals 2,000. So we're trying to figure out how many times were not. Okay, so that's what we're trying to figure out. So if we have 1 equals 2,000, then we have 0.932, what would be left over out of 0.932? Well, if we said 1 minus 0.932, what are we going to have left? And that's going to be 0.068. Okay, so this little piece right here, that is in the not category, is 0.068, and that's what we're trying to figure out. Alright, so we're going to write that as what decimal times of equals is, okay, and then we're saying 0.068 of 2,000 is what number? Okay, we already know 0.068, this is the one that we're looking for. So 0.068 of 2,000 is what? So 0.068 times 2,000 is what number? Or the ones that are not. Alright, so all we have to do is multiply these. So 0.068 times 2,000. So 136 is the answer to that one. So if it starts to get confusing with these, draw a diagram if you need to. Remember, the whole thing is always going to be represented by 1. Remember how before when we did percents, we represented the whole thing with 100%? On these, you're representing it as 1. So it's basically just like you turned your percents into a decimal number. Alright, the next one is consecutive integer word problem. In algebra, we study problems whose mastery will provide the skills necessary to solve problems that will be encountered in higher mathematics, and things like chemistry and physics. So problems about consecutive integers are one of these types of problems. Alright, so consecutive integers, the first example says, find 3 consecutive even integers such that 5 times the sum of the first and the third is 16 greater than 9 times the second. Alright, so that sounds confusing. So we're just going to say, alright, consecutive means one right after the other, and consecutive even integers would mean like 2, 4, 6, 8. We have to have even numbers. Alright, and then it's asking us to find 3 of them. So we're going to call the first consecutive even integer, we're going to name it n, as number, and then the second one, we're going to name it n plus something. Now if they're even integers like 2, 4, 6, 8, if 2 is the first one, what did we have to add to get to 4? Well, we had to add 2. And then what did we have to add to 2 to get to 6? Well, we added 4. So the first one is n, the second one is n plus 2, and then the third would be n plus 4, because that would get us to 6. Okay? Now we just read the problem and turn it into an algebra problem. Find 3 consecutive even integers such that 5 times the sum of the first and the third. Alright, so we got 5 times the sum of first and third. That means that we're going to have to do the first times the plus the third, and then multiply all that by 5. So the first is n, and the third is n plus 4. Okay, so that is the first and the third, and we need 5 times that. So we're going to multiply all that times 5. And they're saying that that is 16 greater than 9 times the second. So first I'm going to write equals, and then 9 times the second, which is n plus 2. Now it said that this is 16 greater. This side is 16 greater than this side. So what do we have to do? Add 16 to that side to make them even. Alright, let's read it again and make sure that's right. So find 3 consecutive integers. Here's our integers. Even integers such that 5 times the sum of the first and the third, 5 times the sum of the first and the third, here's our first, here's our third, is 16 greater, this side's 16 more, so we had to add 16 onto this side, than 9 times the second, and the second is n plus 2. Alright, now all we have to do is solve. So n times 5 will be 5n, and then that's the same thing, another 5n, and then 5 times 4 is 20. And then right here we would have 9n, and then 9 times 2 is 18, and then plus 16, and then we're going to add like terms, so 5n and 5n would be 10n plus 20 equals, and then here we got 16 plus 18, bring our 9n down, 16 and 18, 6 and 8 is 24, 44? No. Where's my calculator? 6 and 8 is 14, 34. Okay, now we got to get our n's on the same side. Just like we would solve a regular problem. And we get n plus 20 equals 34, and then we got to subtract this 20. N equals 14. Now that's not the answer, that's just our first integer is 14. So if our first integer up here is n is 14, our second one is going to be 14 plus 2, 16, and then our third one is going to be 14 plus 4, 18. And you see how there's 3 consecutive integers, they go in a row, they go in numerical order, and they're even, 14, 16, 18. The answer to that one is 14, 16, 18. So on these, if it asks you for 3 integers, you're going to have 3 numbers in a row for the answer. Alright, I'm going to try another one here. Find 4 consecutive integers. 3 wasn't bad enough. Now we got to find 4. Get another marker. 4 consecutive integers. So 4 consecutive integers. These are not odd or even. So we're going to have our first, second, third, and fourth. And we're going to name the first one n. The second one is going to be n plus 1, because we're not looking for even integers, we're just looking for them in a row, so like 1, 2, 3, 4, 5. So the first, if the first was 1, the second was 2, we would say plus 1. If the third was 3, we would have to say plus 1 plus 2 gets us to 3. So n plus 2. Fourth is n plus 3. Okay, there's what we're going to name each of those, first, second, third, and fourth. Alright, find 4 consecutive integers such that 5 times the sum of the first and the fourth. So 5 times the sum of the first and the fourth. The first is n, and sum means we're going to be adding them, and the fourth is n plus 3, and it says 5 times that sum. So you multiply all that times 5. 5 times the sum of the first and the fourth is 1 greater than 8 times the third. So I'm going to say equals 8 times the third. The third is n plus 2. And it said this side was 1 greater. So to make it even, I have to add 1 over here. Alright, let's read it again and make sure we've written it down properly. Alright, so find 4 consecutive integers such that 5 times the sum of the first, that's our first, and the fourth, our fourth is n plus 3, yep, is 1 greater, so we add 1 over here to make it even, than 8 times the third. 8 times the third, and the third is n plus 2. Alright, now we just solve. So we get 5n plus another 5n plus 15 equals 8n plus 16 plus 1. Now we just add our like terms, so we'll have 10n plus 15 equals 8n plus 17. Okay, and now we got to get our n's on the same side, so minus 8n. We're going to get 2n plus 15 equals 17. Now we're going to have to subtract 15. Get 2n equals 2. And then we divide by 2. And we're going to get n equals 1. So that's not our final answer. That just means n up here, our first integer, equals 1. So our second integer would equal 2. And then our third would be 3. And then our fourth would be 4. So the answer would be 1, 2, 3, 4. Alright, so your homework is going to be lesson 6. And that's the one you're going to bring to class on Wednesday, is lesson 6. And if you have any problems, just send me a message. I can make a short video. I can do one of the practice problems for you. If you don't understand it, just leave them blank, and I can do them in class on Wednesday. Alright, see you guys on Wednesday.